Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video. And today's video is about another interesting topic in computer organization and architecture. We're going to see memory address and its allocation. So in this video, we're going to see how the memory address has been organized and what is meant by byte addressability and what are the various byte address and its organization. That is what we're going to see. So first let us start with what is memory, right? We have already seen in first unit that memory is the very important subsystem in the computer, right? And we have memory, the very important memory is primary memory and secondary memory, right? And very importantly, in primary memory, we have seen what is RAM, what is ROM, and all those things, right? And memory is consist of lot of storage cells, that is semiconductor storage cells, which is capable of storing single bits, that is it can able to store one bit information, that is zeros or ones. In order to access those bits, we cannot be able to access each bits individually. So it is organized in such a way that it is organized in groups, right? So that group of bits is called as words. We have already seen that in first unit as well. The group of bits is called as words, okay? And this word will have infinite number of bits inside it, right? If you say this is a word, you'll have number of bits in it, okay? And the number of bits in the word is called as word length. And usually this word length will be from 16 to 64 bits, okay? And whenever we need to access any particular word, it will be stored in the memory, right? We need a peculiar number or specific address to access that particular word. For example, you can see this particular diagram. The words will be organized in memory like this: first word, second word, third word, and like this, right? You have a list of words here. But in order to obtain the information, we know that processor is the one which performs all the operation, right? But in order to perform all the operation, processor will fetch the instruction from the memory, right? And you got to understand that even though processor performs all the operations, right? But the operations are executed based upon the information, the instructions which is stored in the memory, correct? So from memory, it is sent to the processor, and processor process that information and sends the result back to the memory. This is the normal organization, right? We have seen this in organizational concept of computers, okay? So now, if the processor needs information from the memory, if the processor needs some information from the memory, that is in order to execute a particular instruction, right, it has to fetch that particular instruction from the memory, right? So in order to fetch that particular instruction, each and every instruction must be allocated in the memory in such a way that it should have a specific number to identify that particular instruction, correct? If this particular processor need fourth word, right, then definitely this fourth word must be identified by using a special number or some particular concept, right? So we need a particular number to identify that particular word. That particular number is called as address, okay? So in memory, you have to understand that in memory, the words are organized in such a way that each and every words will have the corresponding number, which is called as address. Only with the through address, we can able to identify the particular word, and that particular word can be read to the processor, okay? So now each and every data is stored in the form of words, okay? And these words can be 8 bits, 16 bits, 32 bits, or 64 bits, okay? And we know that 8 bits is 1 byte. 8 bits is equal to 8 bits is equal to 1 byte. 1 byte, okay? Now we got to understand that we know that computer is like we normally use computer which is a 32-bit or 64-bit operating system, correct? What is that? That is the memory location represents 32 or 64, correct? So you have to understand that each and every byte, 1 byte consists of 8 bits, okay? So if we say it is 16 bits, it is 16 bits, we can also say that as 2 byte, correct? 2 byte, that is 2 into 8, that is 2 8 bytes, okay? And similarly, the 32-bit word can be represented as 4 bytes, okay? That is 4 8 words, that is 4 8 bytes. Correct? Sorry, 4 bytes, right? That is 4 distinguished words. Okay, so that is about bits, words, and as well as byte. And you want to understand right now what is memory, right, and how it is organized, and what is word, how it is organized. Now you want to understand like each and every word will have a unique identifier that is called as address. Only through that identifier, the processor can able to fetch the instruction from the memory. Okay. So now we want to understand what is address space, right? Address space is uniquely identifiable location in the memory. That is the total identifiable location in the memory. That is, say for example, if we say it is a 32-bit address, then the address space is to the power of 32. Right. And if it is 64 a bit, you can say it is to the power of 64. That is the total location. Right. That is called as address space. And we know that we will represent something like kilobytes, terabytes, and gigabytes in processor. Correct? That completely relates to this particular address space. Okay. The number of memory units, that is kilobytes, is to the power of 10, and megabyte to the power of 20, and gigabyte to the power of 30, and terabyte to the power of 40. Okay. Now you understand right now what is address and what is words. Okay. And you want to understand what is byte addressability, right? What is byte addressability? We know that each and every word, that is this first word, second word, third word, fourth word, like this, right? Every word is organized in the memory like this. Okay. And each and every word is addressed, is accessed through this particular number. This is called as address. This is called as address. Okay. And now there is something called byte addressability. That is, each and every word can be identified using this particular address. Okay. And this address can be a byte addressable one. Right. What is byte addressable one? As I said, if it is 16 bits, if it is 16 bits, then we can call it as 2 bytes. You can call it as 2 byte address. If it is 16-bit address, you can call it as 2 byte address. Similarly, if it is 32 bits, we can call it as 4 byte address. 4 byte address. Which means for a 32-bit memory, for a 32-bit word, right, you can represent the memory allocation will be like this. Like it will be split into 4 bytes. For 32 bits, it will be separated into 4 bytes. That is 0 to 4 and 4 to 8, right, and 8 to 12, like this. Okay. So each and every address will be in the multiples of 4. Okay, because it is a 4 byte address. Okay. And if it is 16 byte address, you start with 2, 2, 4, like that. Okay, 0, 2, 4, like that. Okay. So that is known as byte addressability. Right. Not only the word, that is, we said that each and every word is being identified using this address. Right. Similarly, each and every bit, right, each and every bit has a bit location. Okay, we know that already. Right. Like BCD, you have lot of different binary representation, that is binary coded decimal, signed binary, and all those things. Correct? Right. So each and every bit, you can see B0, B1, B2, B3, like that. Right. Each and every bits have its own position. Okay. And as I said, you can see this, if it is a 32-bit word, it can be split into 4 8-byte, that is 4 byte words. Right. It can be called as 4 byte words, or it can be called as 32-bit word. 32-bit, or it is a 4 byte. Okay. And this is called as byte addressability, addressing the word using bytes. Okay. And this byte addressability of 2 different types, right? That is, there are 2 different assignment of byte address, right? What is that? That 2 assignment is big Endian and little Endian. What is big Endian and what is little Endian? Okay. These are the 2 assignments for byte address. Okay. Now, make it very simple. Don't get confused. Okay. You know what is MSB? What is MSB? And what is LSB? Right. Most significant bit and least significant bit. Correct? So this is the most significant bit and this is the least significant bit. Correct? Now we are going to see what is big Endian and what is little Endian. Right? So big Endian, in the sense, understand one particular concept. We are going to represent using byte address. You're going to byte address. That is the two representatives for byte address. Okay. So if the MSB of the number, right, is represented by using lower order bytes, lower order byte address, then it is called as big endian, right? And if it is represented, that is if the LSB is represented by higher order bits, then it is called as little endian. Okay, you can see here, right, as I said before, you can see here, right, 0, 1, 2, 3, right, and again second row is 4, 5, 6, 7, correct? So this is, give me a minute, right, so 0, 1, 2, 3, like you can see this 0 is the lowest byte address, right, when compared to 3, correct? And similarly, 4 is the lowest byte address when compared to 7, okay? So now, if you are going to represent the MSB using the lower order byte address, you can see here, the MSB is represented using 0 and 4, then it is called as big endian. This is called as big endian system. Okay, and if you're going to use higher order byte address, you are going to use higher order byte address. You can see in this row, this is the higher order, and in this row, this is the higher order. If you're going to represent using higher order byte address, then it is called as little endian process. Okay, and from the name itself, you can understand what is big endian, little endian. You don't want to get confused. Just understand one particular thing. That is MSB alone, right? If you are going to use lower byte address for MSB, then it is called as big endian. Okay. If you are going to use higher order byte address to represent MSB, then it is called as little endian. Okay. Right. You can also understand in this particular way. You can see that we are saying that big endian. So the MSB is represented using the lower order bytes, right? Similarly, little endian we are representing the MSB using higher order byte address. Okay, and we can also say in different way, that is this it is big endian. So at the end it will be big. Okay, so it is big endian, and you can see here that is at the end you will have little, so it will have little endian. You can also remember in this particular way. Right. So far what we have seen is we have seen what is address, what is word, what is bit, what is byte, and what is byte addressability. Right. And in byte addressability we have seen what are the different types of representation. Okay. And you got to understand what is word alignment. Right. And before going to this word alignment, you can also see this particular big endian. You can see here, right, each and every word starts with 0, 4, and then 8, and then 12, like that. Even here it's 0, 4, 8, 12, like that, because this is a 32-bit address. This is a 32-bit address. So if it is 32-bit address, it will be 4-byte address. So it will start with 0 to 4 and 4 to 8, like that. Okay, right. And word alignment, like as I said, we know that what is byte address now, right? And if it is 32-bit, it has to be like 0, 4, 8, like that, right? And similarly, if it is 16, it is 0, 2, like that, right? So if your word, the memory allocated in the memory, the word allocated in the memory, right? If it has the address in this particular order, like in this particular order, if it obeys this particular order, then it is called as aligned address. It can be called as aligned address. Okay, you can see here the words are said to be aligned in memory if they begin at a byte address multiple of number of bytes in the word. Okay, so that is the case. Okay, you can see here if it is 16, 16 is a 2-byte address. 16 is a 2-byte address. So it will be starting from 0 to 4, like that. Okay, and if it is 32, it will be a 4-byte address. It is a 4-byte address. So it starts from 0, 4, and 8. Okay, and if it is 64, it is an 8-byte address. Okay, right. So it starts from 0, 8, and 16. Okay, so if this follows, if the word is aligned in this particular manner, then it is an aligned word. It is called as an aligned address. If it doesn't follow this particular thing, then it is called as unaligned. Okay, right. And now we have seen what is address and how we have to access that particular address. Okay, similarly, we can also access numbers, characters, and character strings in it. Correct? right? So in computer, if you want to access a number, it is accessed through word address, because each and every word is stored in a particular, each and every number is stored in a word, okay, and it can be accessed through word address. Similarly, individual characters can be accessed using byte address, right? And you know what is variable length, string of variable length? For example, if we have a sentence, okay, and it has characters of variable length, okay, then how is that it will be represented? Okay, it will be represented, that is the first letter, right? The byte address of the first character of that string, right? It will be the first byte address, right? The first character. For example, if it is a good ball or a good boy, something like that, right? So this particular character, right? So the address, the byte address of this particular character is the first address, okay, and the second character, right, the second word, the second character will be the subsequent words, okay, like that. If it is a variable length, we can able to assign byte address for that, okay. And similarly, length of the string can be identified by two different ways, that is by assigning, right, by assigning a special character, by assigning a special character at the end of the string. At the end of the string, if you assign a special character, right, you can assign a special character stating that that is the end of the string. You can mention it as an end of a string through that special character. Or what we can do is we can use a specific memory location or a register with some number identifying or indicating the length of the string. Okay, so for length of the string, we can represent by using two different ways. One is, right, the first one is by using special character, and the next one is by using a memory location or a register with a particular number stating the length of the string. Okay, and the very important thing in this particular concept is memory operation. Okay, and we know that the computer execute the instruction based upon the performs all the operation based upon the instructions which is stored in the memory, right? So that particular instruction is called as program, right? The list of instructions is called as program, and inside the program you will have data and variables, right? That is called as operands, right? And we know that whenever you need to perform any particular operation, right, all the operation is carried out in the processor, but the instructions are stored in the memory, right? So in order to perform all the instruction, all the operation, the instructions first fetched from the memory to the processor, right? Memory in the processor varno, and then processor will perform that particular operation, right? Whenever the processor needs any particular data, once again it will go and ask the memory, correct? So the basic operation here is, right, load operation and store operation, right? So load operation is whenever the processor needs any information from the memory, right? That is, in order to read or fetch the data from the memory, load operation will be used. Okay. So how it will perform? That is, whenever the processor needs any information, it will send the address. We know that each and every word has a particular number, right? So the processor, what it will do is, it will mention the address location, and it will initiate and it sends a request, read request. Okay. Once the memory receives the read request, what it will do is, for example, if it is add B1 and B2, this is the instruction, okay, and it is in some location, say for example, if it is in address of 8, just for an example, okay. Now, what processor will do is, it will send the number 8 with a read request. So now the memory, after receiving this request, it understands that processor needs this particular information, which is at the location 8. Okay, so it will fetch this information to the processor, right? That is, the processor will fetch the information from the memory, right, through this particular process. Okay, this is called as load operation, right? And store operation is write operation. That is, the processor will store some information to memory, right? For example, if it performs addition operation, right? It performs addition operation, addition of B1 and B2, it is performed and it has a result. Now the processor, what has to do? The result has to be stored in the memory. Once again, the processor, what it will do is, it will send the address location and the result to the memory. So now the memory, what it will do is, after receiving the particular result, it will store that information in that particular memory. right? It will store that particular result in that particular address location. Okay, this is called as store operation, right? So today what we have seen is we have seen what is memory, how memory is organized, okay, what is bits, what is words, and how words are organized in memory, what is address space, we have seen what is byte addressability, right, and what are the different types of assignments in byte addressability, and you have seen memory operation, right? Hope you understand the concept, right? Thank you, students.
Thank you, students. Thank you for watching. கண்டிப்பாக இந்த வீடியோ உங்களுக்கு எல்லாருக்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்கும்னு நம்புகிறேன். Subscribe Passionate Professor and keep learning. Thank you very much.